Okay, you guys, we're looking at 7-1. The nice thing is, we don't have to graph a thing. How do you feel about that? We don't even have to talk about the unit circle. How do you feel about that? Oh, good. You might be a little misled because you're like, excuse me, I know that that's a unit circle right there. It's just for my starting point. It's just my starting point. Guys, if I were you, I would go ahead and put like just a cute little triangle in there. Cute little right triangle. And we really started our last unit the same way. And we named this point X comma Y. But now what are we going to name this point now that we've got these fancy terms? Instead of X, we could say cosine. And instead of Y, we could say, yeah, you know what I'm saying, people? If there's my angle, instead of saying X or Y, we could say cosine and sine because that's just the X coordinate and the Y coordinate. To get over to that X coordinate, you agree that this X distance on that X axis, this is that cosine. And then that Y distance, this is that sine, that vertical distance. And then what's the radius of every unit circle? Does anyone remember that? Yeah. So you guys, can you remind me what the Pythagorean theorem would look like of this triangle with these values?
Sine x squared x cosine x squared.
Yes, he's saying this squared plus this squared is this squared. Agreed. Perfect. Now, a book is not going to write it that way. A book is going to write it this way. Sine squared x and cosine squared x. 1 squared is how much? 1. So that's why I'm going to write it this way, just so you know. I kind of like it because it's just less things, right? We don't have to write parentheses. The squared has to go in between the sine and the x, and it just means this quantity is being squared. They put it inside there, though. What if we put that little squared right there? It would be only going to the x, you know what I'm saying? So this is kind of fancy. We fancy? Okay. So then, this is the first Pythagorean identity. We should go get it tattooed on us right here because we're going to use it a lot. Right here. Okay, so you guys, this one, we're getting tattooed. Okay, row, getting tattooed. These others, though, so check this out. This one I have written right here. Sine squared plus cosine squared is 1. Cool. This is my 9th year of teaching this. I still don't have these memorized. I do not expect you to memorize them, but I do want you to know where they came from, how I got them. Check this out. Sine squared plus cosine squared is 1. You guys, if I need this to turn into this, sine over what gets me tangent? Cosine. Yes, sine over cosine is tangent, right? So, you guys, Mr. Rowe, you said sine over cosine is tangent. Agreed. So here's my piece of advice, you guys. If I divided this by cosine squared, what would sine squared over a cosine squared get you, do you think? Agreed. Since they're both squared, right? Here they're not squared, so you just get tangent. Here they are squared, so you get tangent squared. If I divide this first thing by cosine squared, I better divide all of them by cosine squared. And let's see what that gets us, you guys. What do you think? One more time, sine squared over cosine squared? Okay, what about cosine squared over itself? Any number over itself is 1. 1 over cosine is secant, therefore 1 over cosine squared is secant squared? Are we down with that? So do we need this memorized? No. Do I need this black one memorized to be able to then divide through by cosine squared? Yes, I do. Exactly, Mar. So maybe what you write on your little page is you let yourself know that this guy, I divided through by cosine squared to get that one. You know what I'm saying, people?
I know what you're saying.
Thanks, Mar. You were just really on my side today. Any ideas about this one? How am I going to go from here to here? Okay, Sky, what's sine squared over sine squared? Psh. What's cosine squared? And I'm going to write this out just so that people might be more visual people. What's cosine over sine? Nice, cotangent. Cosine over sine is going to be cotangent squared. 1 over sine squared is cosecant squared. Yeah? We wish that sine went with secant, but it doesn't. Sine goes with cosecant, right? So what are we going to write on this little ditty? This one was just divided through by sine squared. You guys, let's think back. If secant is 3/2, cosine?
2/3.
Done. You know that secant and cosine are reciprocals. You're done. Cool. You're done. You're done. This one is going to be a little different. Check this out. Cosecant is 4/3. What would I know is 3/4? Cosecant goes with sine. So what would sine of theta be?
3/4.
Okay. And then they're asking for the tangent. You're like, I don't know. But here's the deal, people. When does SOHCAHTOA work? In what kind of triangles?
Triangle.
Yes, Marek, thank you. It works in a right triangle. I'm going to go ahead and put my theta here. If the sine of theta is 3/4, what could I label on my triangle?
1.
But don't forget, I'm not in the unit circle right now.
No, I got you.
Sine is what over what? SOHCAHTOA.
Okay, over T.
Okay, so the sine is what over what?
Opposite of our.
Thank you. So do you agree on this picture, the opposite and the hypotenuse are going to be 3 and 4? Could I find this leggedy dag? Because what is tangent? Tangent is what over what?
Adjacent.
Opposite over adjacent, right? So how are we going to find the adjacent?
Opposite over adjacent.
How are we going to find the adjacent in this right triangle? 3 squared plus,
X squared.
sure, something squared, equals 4 squared. 3 squared is
9.
4 squared.
16.
A squared would equal square root of 7. A equals a squared equals 7. Therefore, a is the square root of 7. Perfect. Whew. That's not too gross. It could be grosser. So they want the tangent of this angle. Tangent's going to be what over what?
Opposite over adjacent.
Opposite over
7
adjacent.
over 4.
Very
Or
good.
7 over 3.
Whoa.
Thank you, Mark.
What's the opposite going to
3
be?
over root 7.
3 over root 7. Go get my root out of the denominator. Beautiful, Gusty. He's saying 3 root 7 over 7. Sorry for my colors getting together. We're trying to simplify these 3 terms that, just so you know, this is cosine of x times cosecant of x times the tangent of x. And they're just saying, can you simplify that out for me? Simplify it down. So we're typically trying to simplify these just to one term, if you will. And my biggest piece of advice to start that is always put them in terms of sine and cosine. You agree this is already in terms of sine and cosine, the first one. So I'm just going to leave it. Let's just say cosine. How can I rewrite cosecant in terms of sine and cosine? Beautiful. Notice how I write this. I'm keeping them on kind of like 2 different levels, if you will. My numerator's all in one and my denominator's all in the other. And I'm doing that for a reason you're going to see in a second. How can I rewrite tangent in terms of sine and cosine? Say that again. Sine gerene over cosine gerene. This we often struggle with. What if I said this? Hey, what's 9 times 1/6 times, okay, I'm going to go 9 times 1/7 times 7/9. Anything that we can do with that? Cancel what out? 7 over 7.
9.
9 over 9, what's my answer?
1.
Can I apply the same thing here?
Yes.
Yes. So you guys, you've done this before. You just haven't done it with these words yet. Can my sines cancel out? Yeah. What about my cosines? What am I left with?
1.
Do we simplify this problem in your mind?
Yeah.
I'd say we simplified it. Question. What if it was 9 plus 1/7 plus 7/9?
Common denominator.
I'd have to get common denominators. My question is, can I cancel those? I cannot because of the adding or subtracting. I'm here to tell you, anytime we've got this adding and subtracting between them, we cannot cancel them out. Okay? So I'm going to have to say that. Miss Queen's going to have to say that 200 times a day. We're going to say it because we love you. And this is an innocent mistake a lot of people make. When we're multiplying, cross everything out. When we're adding and subtracting, Here we go. It says simplify each expression. Again, you guys, maybe you write yourself a note. Write in terms of sine and cosine. If you do that, that's a really good step to start. It's going to make your life a little bit easier. How could we write cosecant?
1 over sine.
Thank you, Sev. How could I rewrite cotangent? I could do 1 over tangent, but look at what we just wrote down. If I want to write them in terms of sine and cosine, so you're not wrong. Cotangent is 1 over tangent.
1 over sine over cosine.
Cosine over sine is cotangent, right? Because tangent is sine over cosine. Cotangent is its reciprocal. So are we cool with saying that that's the same as cosine over sine? What can cancel? The signs can cancel because they're both in the denominator. Let me remind you why that works. If I am dividing by a fraction, what's that the same as multiplying by?
Tangent.
The reciprocal. Agreed. It's the same as multiplying by the reciprocal. And so I'd have a sine over a cosine. That's why these cancel out. That's why those cancel out. It's because we're multiplying by the reciprocal. What's left when I multiply straight across now? 1 over cosine is the same as secant. Would you say that we simplified something given to us kind of gross? We simplified it into one term. We got rid of the division. Yeah?
Yes.
For example, on this one, do you agree if I were to write things in terms of sine and cosine, this one's already in terms of sine and cosine. This one's already in terms of sine and cosine. This one's not. And again, we could write cosine squared over sine squared. We could. But I want to show us a new strategy. What if I gave you a real world problem like this? 3 plus 9 is the same as 3 times what?
4.
3 times, sorry, I did not say that out loud. I did not say that how I was meaning to. Sorry, if I factored out a common factor, what would I have left?
3.
Over here I would. And a 1 right there, right, is 3 times 1, my 3. And 3 times 3 gets me my 9. Because they had a common factor of a 3, right? Sorry, I did not ask that question, hopefully, at all. Is there anything we could factor out here? We could factor out a sign, row. If I take out a sign, what's left? Meaning sine times what would get me that sign?
A cosine.
Close. Sine times what is going to get me this one? He's like, oh, we got to just start with the first guy. That's just going to be a 1. Sev, you okay with that, Bubba? Meaning sine times 1, we got to get what we started with. Just like here, 3 times 1 got me that 3. Sine times what is going to get me sine cotangent squared? Cotangent squared, he said. And let me say that one more time. When you distribute this through, I'll get what we started with. Are we there? Okay. Then you're like, great. I don't know what to do from there. I don't blame you. You've never seen this. But I'm here to say, when you've got a 1 and something squared, we might want to look back on that front page. So from the front, is this a thing? This is a Pythagorean identity. If 1 plus cotangent squared is there, and it's also here, what could I replace this with? You're saying they're equivalent. So you guys, I would have sine times cosecant squared. Beautiful. Thank you for that. We made a substitution of this right there. So good, Ro. Ro, maybe you are going to love this. Okay. I love it. You guys, then could we put this in terms of sine and cosine? You guys, how could we rewrite cosecant squared? 1 over sine to the second. Could anything cancel out because I'm multiplying these? A sign could. Okay, Ro, dude, you are en fuego.
Please come to the front office. Ben Richardson, please come to the front office.
Wouldn't one sign cancel and one of those signs cancel? What am I left with then? 1 over sine, which again isn't probably the simplest because it's got division in it. 1 over sine is the same as, thanks, Sylv, cosecant. We done. You guys. This guy. Do we have something that we could factor out of all 3?
No.
We don't, right? Could we put them in terms of sine and cosine? We could, and you might be a little nervous. And now, actually, Teddy, I will address it. He's like, well, couldn't we factor out an These trig functions cannot exist without an angle. So we can't take an x away from cotangent. Cotangent would be naked, and they can't be. Okay? It's like when we go to plug that into our calculator. When I hit tangent, look, it's saying tangent of what? It's got to be something there, right?
What is going on up there?
You guys, let's go rewrite this in terms of sine and cosine. My cosine, what are we going to write for cotangent? What over what? Cosine over sine. Plus, that little guy, we can't do anything with it, right? Since these are being multiplied, I could have canceled things out if they matched on the top and bottom, but they don't, right? Let's just multiply this together. What would we have up top? Beautiful. Cosine squared over sine. What's the matter? Question, you guys. What if I said, hey, what's 2/9 plus 9? That's what we're dealing with. Adding and subtracting is annoying. What do we have to do in order to add fractions?
Common denominator.
Woof, right? Totally. Common denominators. What are we going to multiply this one by?
Wait,
9/9, yeah? 9/9 is the same as 1, Mar. That would get me 2/9 plus 81/9 is going to get me 83/9. I'm leaving that there because we're comfortable with that. This is what we're uncomfortable with, but we're doing the exact same thing. I'm going to go put this sign over 1. What denominator does it need?
Sine.
Needs a common denominator sign. So you guys, I'm going to say, all right, I need a sign on the top and bottom. Just like before, I didn't change my 2/9. I'm not going to change this cosine squared over sine. He's chilling. Cosine squared over sine plus, Skylar's so sad at this, sine times sine, sine squared over sine. Thanks, guys, because we multiplied straight across. So then, Skylar, if I were you, I would go like this. Boop. Do we have comdoms?
Yeah.
Common denominators. What did we do once we had comdoms?
Add the cross.
We added the top, right? 81 plus 2 is 83. Here, we're going to just write it out. Cosine squared plus sine squared. And what do we do with the denom? Sine, like 9, it just stays, right? Okay, and you're like, man, dude, if the whole deal of this was to simplify, I feel like we did not simplify. But we're getting there. What? Ugh, guess why we can't cross out? The adding is the worst. Now, Vi, if that was a multiplication sign, you're right. One of these signs would cross out. Adding is the worst. Same with subtracting, okay? You guys, go look at your tattoos that we got. What does this equal?
1.
Doesn't the sine squared plus cosine squared equal 1? Hey, so can I replace that entire numerator with 1? What? Did I make? No, focus. 1 over sine is the same as? Cosecant. Did we simplify it? I would say yes. What's up, Ad? You good? How about this one? Do you guys want to go put this in terms of sine and cosine?
No.
It already is, right? We can't do it. Does it have anything in
Yes,
common?
Did you make it a 1?
Take what? Make what a 1?
Square plus cosine squared.
Ooh, do I have a sine squared plus a cosine squared? Dang it, but we're close. Like, I hear what you're saying. We need sine squared plus cosine squared. Do they all have something in common, though? Does this term have something in common with that term? What can we factor out? A cosine squared. Take it out. What's left if I took out a cosine squared? Nice. Cosine squared times sine squared gets me what I started with. Then what? Cosine squared times what gets me negative cosine squared? Very good, you guys. And now you're like, okay, I don't see how this is simplifying. Ooh, I love that you just flipped your page. Did you just flip your page? Oh, I thought you did. Here's the deal. If we go back to the front, from the Pythagorean identity, I need this to turn into that. Can I?
Yes.
Yes. Can I subtract that 1?
Yep.
I'm allowed to. Could I do that by just saying, I'm just going to move it from both sides? So I'd have a sine squared minus 1. If that's all I want on this side so that it matches that, how would I get rid of that cosine squared? Subtract that over. So what was sine squared minus 1 get equal? Negative cosine squared. So what can I replace this with? Negative cosine squared. Okay? Is it going to take us a while to get used to these Pythagorean identities? For sure. That's why we're going to practice. So this little guy, cosine squared, stays. What are we replacing sine squared minus 1 with? Negative cosine squared. When we multiply those, cosine squared times cosine squared would get me cosine to the beautiful. What's in front of it? Beautiful. He's saying it's got to be a negative because this one was negative. 18. I feel like you're going to dig 18. How might we rewrite 18?
How would you, what?
Cosine A over sine A.
Beautiful. She's saying, okay, cosine over sine is cotangent. Can we divide by tangent?
Yeah.
What's tangent? Sine over cosine. Can I cancel anything right now? Sylvie's saying, no, those denominators don't match. Agreed, Sylv. That's great. So you guys, let's write it out. If I've got cosine of A over sine of A, I just brought this top over. This was right here. Dividing by this is the same as multiplying by.
Cosine over sine.
Beautiful. Same as multiplying by cosine over sine. Does anything cancel? We're multiplying, so we could be able to cancel, but does anything cancel? No. Right? Because I don't have, yeah, so let's just multiply straight across. Cosine times cosine, row. Cosine squared. Sine times sine. Sine squared. Man, it'd be really creepy if we taught whispering. You guys, what is cosine over sine? Cotangent. So therefore, what would cosine squared over sine squared be? Beautiful. Okay, last one, you guys. Whoo-wee! What if I've got 7/9 plus 7/4?
Common denominator.
Because we're adding. We got to do common denominators. What are we multiplying this one by? 9/9. Thanks, everyone. What are we multiplying this one by? 4/4. Okay, what would we get on the top here?
28
28
over
36 plus
20, no, 30.
63 over. Final answer.
28 plus 36.
91.
36.
Beautiful, Mar. So, again, I'm going to leave that off to the side just so that we've got something a little bit more relatable to rely on. Yes. Okay. So, what do you think that we should multiply this beautiful thing by? What does this left side need?
52.
That's the problem number.
Negative or minus or something.
So, over here we multiplied by 4/4. Where'd that come from?
7/4.
Came from that denominator, right? So what?
1 minus.
One minus
Exactly. She's saying, okay, I got to do that entire denominator. 1 minus the cosine of x. 1 minus the cosine of x. What are we multiplying this one by?
1 plus cosine.
Beautiful, Sev. 1 plus cosine of x. This technically is the conjugate, and I'm going to tell you why we love the conjugate. Let's do this, though. Up top, you down with a little distributing? Let's distribute this top. What's this going to get me here? Sine of x. This is the last one, guys. Then we'll take a little break. And then what? How are we going to write that? Minus. Then? Yeah. You guys, you can just write minus cosine sine. Row. What if Teddy wrote minus sine cosine? Makes no difference. Doesn't matter what order we write them in. Yeah.
And we have gone to the other page and simplified.
What would the denominator be on this one? I love this. Here we go. What's 1 times 1?
1.
Okay. This is the why we love the conjugate, you guys. What's 1 times cosine? Cosine. Guess what this is going to get me?
1.
Negative.
Oh, cancel out.
No cancel out.
That's the whole point of the conjugate. So if you want to write it, we're welcome to. We'd have plus a cosine minus a cosine. With the conjugate, they will always cancel out those middle terms. Pew, pew. What would we end with then? Right here.
Cosine squared.
What's in front of that cosine squared?
Squared.
Negative.
Oh.
Minus that cosine squared? Sound good?
1
Yes.
minus cosine squared.
Great. It's on the bottom, right? Let's go do the same-ish thing over here. What's sine times 1 going to get me? Sine. And what about sine times cosine? Sine, cosine, here's the deal. Since I wrote cosine sine before, I'm going to just stay consistent.
Yeah.
You okay with that? So I'm going to say plus cosine sine, just so it just sticks out to me a little bit more. Okay, here we go. We're almost there, people. This is another conjugate. Let's see if things cancel out. What's this going to get me? 1. Then, what's this?
The same thing.
What's this?
You're making comments about it.
Yeah, I am. But we got a cosine?
1 minus cosine squared x.
Well then. And we get another negative cosine, so they're going to cancel out. So we got minus cosine squared over there. Beautiful. Whew. Now that we got condoms, look what we did over here. When we got condoms, we added those neumies. Can we add these neumies? You like my shorthand? My short words?
Yeah.
It's just too much to say. Okay, let's add our neumies. You guys, what is 1 sine of x plus 1 sine of x? I'm taking that plus that. 2 sines of x's.
Sine of x.
What about negative cosine sine plus a cosine sine? They're out. I agree. They gone. Psh, psh. What's this over?
1 minus cosine squared.
Good. Here's the deal. Hey, Sev, you agree I got a squared down here and a 1 down here? I don't mean that sassily. This is new to us. What is sine? We know sine squared plus cosine squared is 1. Last time Teddy said just move things around. Teddy, you're so right. Can I move this over there to be 1 minus cosine squared?
Yeah.
Wouldn't it match then? So what is 1 minus cosine squared going to equal?
Negative sine squared.
Close.
Sine squared.
Wouldn't it just be a positive sine squared because I only have to move that? So you guys have got 2 sine of x's on top. And then you're saying it would be the same as sine squared on the bottom? You guys okay with that? Let me say that one more time. Here's how we did that. I can subtract my cosine squared of x. These cancel over here. So I'm left with sine squared is 1 minus cosine squared. I just moved this little friend over. I said, Addie, go get a new seat. But you're still in 8th period, you know?
That's so mean.
You guys, can anything cancel now?
Yep.
Because I don't have any adding or subtracting going on, right? Can I say this sign is going to cancel out with one of those? And I'm left with 2 over sine.
That's brilliant.
2 over sine, isn't that the same as 2 times 1 over 1 over sine? And 1 over sine is, you got it.
You know who else doesn't have space on their paper?
That one was a lot though, you guys. Do you see how we took that last step? 1 over sine is cosecant. That's where that came from. We are going to be uncomfortable. Whew.